1.3, arithmetic sequences. What an arithmetic sequence is. It is a sequence in which the difference between each term and the preceding term is always constant. I'll give you this sequence. 2, 6, 10, 14, 18, and so on. If the sequence u sub n is an arithmetic sequence, for each n greater than or equal to 2, the term preceding u sub n is u sub n minus 1. If you have u sub n, the term before it is called u sub n minus 1. If we have u sub n, the term before that is u sub n minus 1. The difference between them is u sub n minus u sub n minus 1. We call that a constant d. So u sub n minus u sub n minus 1 gives us our constant d for all n greater than or equal to 2. An arithmetic sequence can also be expressed in a form in which a term of the sequence can be found by determining its position. This is called explicit form of an arithmetic sequence. Explicit form is u sub n equals u sub 1 plus the quantity of n minus 1 times d for every n is greater than or equal to 1. U sub n equals. What is u sub 1? What is u sub 1 talking about? The first term. I take the first term and I add it to n minus 1, which is the term number minus 1, times d. What is d? The constant difference. Now I'm going to flip back for a second. Here's our sequence, right? I have 2, 6. Yeah, let's write in highlighter. That'll work good. 2, 6, 10, 14, 18, yada, yada, yada. Let's write this recursively. Recursively is what we did. This one would be u sub n equals, okay, this one would be u sub n minus 1 plus 4. Because what's happening every single time? I'm adding 4. Two other things I'm missing here. Two other points I'm missing here. First thing I have to write, n is greater than or equal to 2. The second thing I have to write is u sub 1 equals 2. These are the three things you should have. That's explicit, or recursively. That's the old way. The new way. This is explicit form. U sub n equals. What is my first term? 2 plus. Now, you can write it d here, or you can put d out front. What is my d? What is my difference for every single term? 4. 4 times n minus 1, n is greater than or equal to 1. Where did I get 4 from? 6 minus 2, 4. 10 minus 6, 4. Every single term should be 4. That is written in explicit form. Where did the 2 come from? It's the first term. That's it. N is always there. So if I wanted to find what u sub 50 is, what we did in the last couple sections, you'd have to go through and do u sub 1, 2, 3, all the way up to 50. Now we don't. To find what u sub 50 is, I do 2 plus 4. What's n? 50 minus 1. To find the 50th term, I just put in 50 for n. And I'll just use the calculator. 2 plus 4 times, I'm not going to write 50 minus 1. I'm just going to write 49. The 50th number would be 198. If the sequence u sub n is an arithmetic sequence with u sub 1 equals 3 and u sub 2 equals 4.5. And it's as its first two terms. We're going to find the common difference. We're going to write the sequence as a recursive function. And then we're going to write the first 7 terms. And actually, let's not write it recursively. Let's do it explicitly. Finding the common difference. What do I get for the common difference? How do I find the common difference? 4.5 minus 3. You got to pay attention to the numbers. 2 minus 1, I'm good. So 4.5 minus 3 is 1.5. That is my D. That is my common difference. It will change every time by adding 1.5. Write it as an explicit function. U sub n equals 3. Why 3? That's the first term. Plus 1.5. Now, I don't care if you throw it on the beginning or the end. Times n minus 1. N is greater than or equal to 1. Because I need to know the first term in order to find the second, third, fourth, fifth. They give me the first term. So I have to know the first term. I can use I don't need to know the second term. I can figure that one out. But without... No, because I don't need this. They don't have to tell me this. They could have told me u sub 1 is 3 and the difference is 1.5. I could use this information to find 2, to find 3, to find 4. Write the first 7 terms. Okay, the first term is 3. The next one's 4.5. Do not write u sub 1 equals u sub 2. Just use sequence notation. The next one's going to be 6, 7.5, 9, 10.5, and 12. That's answer to part C. Those are the first 7 terms. And actually the sequence keeps going on forever. We're going to find the 30th term of an arithmetic sequence whose first 3 terms are 5, 9, and 13. I want to see if you can set it up. What's the difference for this function or this sequence? The difference is 4. Writing it explicitly, what would it be? U sub n equals, where'd you get 5 from?
On the first one.
First term. Plus 4 times n minus 1. And I'm just going to tack on n is greater than or equal to 1. That's it. To find u sub 30, just plug 30 in for n. 5 plus 4 times, I'll write 30 minus 1 for when I use the calculator. 5 plus 4 times 29. U sub 30 is 121. It's a lot faster than using recursive formula. If the sequence u sub n is an arithmetic sequence with u sub 6 equals 57 and u sub 10 equals 93, we want to find u sub 1, the recursive formula, the explicit formula for u sub n. In here, I know u sub 6 is 57. U sub 10 is 93. What do you notice about these?
They're not right next to each other.
They're not right next to each other. Normally to find D, you're going to take 93 minus 57. Since they are not next to one another, divide by the difference. 10 minus 6. Now what's 93 minus 57? 36. 10 minus 6, 4. 36 divided by 4 is 9. So the common difference is 9. All right, that part we got. I can write the explicit. Actually, I can write the recursive right now. U sub n equals.
Wait, which one you writing?
I'm going to do the recursive. U sub n minus 1 plus 9. Okay, n greater than or equal to 2. The other thing I need to write is u sub 1 equals, but I can fill that in later. What number? This right here? This, it. Explicitly, u sub n equals. Well, I don't know u sub 1 yet. U sub 1 plus 9 times n minus 1, as long as n is greater than or equal to 1. There's a reason why I did not put anything here. I don't know it yet. I will go back and fix it in a minute. I know I can. But now I have it written there. I need to find u sub 1. I need to pick either one of my values. We'll use the 57 one. Okay. So I'm going to use this. What is u sub 6? 57. 57 equals u sub 1 plus 9. What is my n? N is 6 minus 1. All right, I'm going to go through and solve. 57 equals u sub 1. 6 minus 1 is 5. 9 times 5 is 45. I subtract it over. U sub 1 is 12. U sub 1 is 12. That's a 12. And that's my 12. And there you go. The other way I could have done it is instead of using this value, use this one. And it's going to be set up the exact same way. 93 equals u sub 1 plus 9 times 10 minus 1. It's now 10 because we were talking about u sub 10. 93 equals u sub 1 plus 10 minus 1 is 9. 9 times 9 is 81. 93 minus 81, regardless, what do I get for u sub 1? 12. Doesn't matter which point I pick. You just need to pick one of them. Summation notation. What summation notation is? It is a way to... It is used to find the sum of various terms in a sequence. In other words, if my sequence was 1, 2, 3, 4, 5, summation notation will tell me the sum of those numbers. So it's adding up 1, 2, 3, 4, and 5. Because they're going to sit there and... All right, on here, you have the big giant E. What's that big giant E called? Anyone know? Starts with an S. It's a Greek letter, the Greek letter sigma. It's the summation. K equals 1. That just tells me I am starting for my variable starting at 1. M is where I'm ending at. When I have C sub k, that is just my function. So I have the summation from 1 to m of C sub k equals. What that means is C1, C2, C3, C4, all the way up to Cm. I have the summation from n equals 1 to 5 of negative 5 plus 2n. all I'm going to do is equals -5 plus 2 times 1. The first term plus -5 plus 2 times 2 plus -5 plus 2 times 3 plus -5 plus 2 times 4. Plus -5 plus 2 times 5. I stop there because that's the 5. I can't make this shorter yet. All we're going to do is I'm not going to give you do from 1 to 100. They're going to be like from 1 to 5, 1 to 4, 1 to 3. Those type. Now all I do is do these individually. Okay, 2 times 1 is 2, and a -5 is -3. 2 times 2 is 4, -5 and 4 is -1. 2 times 3 is 6, and -5 is +1. It's going by 2s. The next one's 3, the next one's 5. Here's a question. Why do they go by 2s? Because of the 2 on the 2n, it's just going to jump by 2. Now all I do is add them up. -3, -1, 1, 3, and 5. What's happening here? These cancel out. I'm left with, my answer is 5. This doesn't always happen. It is just for this example where those 2 canceled out. You might have different numbers. The sum of the first 5 terms of the function -5 plus 2n is 5.